Well, hello, statisticians. Welcome back to another fun-filled chapter of statistics. Last chapter we did chapter 2, which was organizing data, putting things into frequency distribution graphs, and also bar charts, histograms, ogivs, all that stuff. And now what we're going to be getting into is called measures of central tendency. That's what chapter 3 is about, and we get to do some more formulas. If you remember that video, let's talk about the mean, the median, the range, and the mode. It's so easy, we'll do it in one day. I don't remember the whole song. But anyhow, we're going to talk about the mean today, and we might be able to get 2 parts of the notes in this video, so let's see how it goes. So our objective is to summarize the data using measures of central tendency such as mean, median, mode, and mid-range. Mid-range might be a new one. I'm thinking you're familiar with mean and median, and probably mode as well. So let's get going. So this is called the mean. So what does the term average mean? In your book it talks about how average is ambiguous, and they say the average man, but that's really no man, you know. It's in loosely defined, they say it's the center of distribution or the most typical case. What are the measures of average called? Now these are the measures of central tendency, which is the name of this unit. What are the 4 measures of central tendency? Well, I've already mentioned the mean, the median, the mode, and the mid-range. So in addition to knowing the average, they say, one needs to know how the data values are dispersed. That is, do they cluster around the mean, or are they spread more evenly throughout the distribution? So this is just a rhetorical question they're asking. Are they, what is the shape, how the data is distributed? Is it clustered around the mean, the middle, and so on? And we'll get into data shapes a little bit later. So what are the measures that determine the spread of the data values called? That's called measures of variation or dispersion, and that's not what we're doing yet. There are 3 measures of dispersion or variation: range, high minus the low, variance, and standard deviation. So those we'll be getting into later. What is traditional statistics? Well, that's where one number likes another number. No, that's something totally different. So we're going to be getting into that. It says another set of measures necessary to describe the data. These measures are called measures of position. They tell where specific data value falls within the data set or its relative position in comparison to other data values. What are the 3 measures of position? Percentiles, deciles, quartiles. You probably have seen percentiles, being the students that you are. Traditional statistics is the measure of central tendency, variation, and position explained in this chapter. So we are doing traditional statistics. If I had an echo, I would do traditional. What is exploratory data analysis? Those are techniques that are used to explore the data to see what they show, such as the box plot and the 5-number summary, which we will get to later. A lot of this stuff is just introducing the whole chapter. So let's get into the meat of the stuff. It's another M word. We got a lot of M words this unit. What's the difference between parameters and statistics? A statistic is obtained by using data from a sample. Parameter is by using the data of the whole population. So that's the difference. General rounding rule: rounding should not be done until the final answer is calculated. That is a very good tip. And if you've had other math classes, when you're trying to figure missing side of a triangle or something like that, you don't want to round till the very end. That keeps your accuracy. What's another name for the mean? Arithmetic average. Or if you're English, arithmetic average. How do you calculate the mean? I think you know. You add up all the numbers and divide by the number of numbers. So the sum of all values of data, then divide by the total number of values. Now, this is where they get into some symbolism. Formula for the sample mean. It means that if you have a sample, you use this X with a bar on the top of it. And they add up all of the little data values in that data set. Divide by the number of values in that data set. And in nice symbolic, remember at the beginning of the year I showed you this is the sum of all the x's or all the data values divided by the number. So that's how they do it in symbolic land. The formula for population mean. And if you look, it's this nice little M looking thing. These are both the same thing. They mean mean. They mean mean. But this one is when they have the whole population, when you have all of the numbers. So you'd have all of these guys added up, divided by the number of numbers. Same kind of formula there. The difference is this is from a sample of numbers. This is from the whole population. That's the difference between that notation. The letters used to denote parameters are Roman. The letters used to denote statistics are Greek. Amazing how they always come back. All right, so here's some data that represents the number of days off per year for a sample of individuals selected from 9 different countries. Find the mean. Well, we know that we're going to take the sum of all of these and divide by the number in our data set. So if we look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in our data set. So if we sum those all up, boom, divide by 9, that gives us the mean. We round to one more decimal place than our data set. So 276 divided by 9, 30.7 days, approximately. It might work. Nah. It's not going to work perfect. All right, so looking at this one, data represents the annual chocolate sales in billions of dollars for the 7 countries of the world. Find the mean. We're adding these all up. There's 7 data values, so we know we're going to be dividing by 7. So we add up all the data values, divide by the lucky number 7, end up with 40.4 divided by 7, $5.77 billion. That's a lot of candy bars. What is the rounding rule for the mean? Round to one more decimal place than occurs in the raw data. So let's look at this table that they have. Oh, yay. Using a frequency distribution, find the mean. The data represent the number of miles run during 1 week sample of 20 runners. So if you look there, these are the frequencies. The way they do this type of mean for grouped data, this is grouped data, is they first find the midpoint of the class boundary. So you have to find the midpoint. Then what we're going to do is take the frequency times the midpoint to get this last column D. So if we start out, recall that to find the midpoint, you add the lower and the upper class boundary and divide by 2. So we take 5.5 plus 10.5 and divide by 2, and that's going to give us the midpoint of 8. So 8 is our first midpoint. I just wanted to review how to find the midpoints, add those together, divide by 2. So we would have, for the first one, 8. We do this for each of these classes. So we're going to divide all those out. So you got 8, 13, 18, 23, 28, 33, 38. Then, because these have different frequencies, so there's more of things in different classes, we're going to take the frequency times that midpoint, and that goes over here in column D. If you see the F, that's for frequency. X sub m is the midpoint, so that's going to be 8. We'll do that for the next one too. 2 times 13, that's going to be 26, so that goes over here in this column, and you continue on. 3 times 18 is 54, 5 times 23 is 115, 4 times 28 is 112, 3 times 33 is 99, 2 times 38 is 76. So we have all these filled out. And then this means the sum of all these. So you add them up. So if we add them up, you get 490. So now to find the mean of this grouped frequency, you take the sum of this guy, the 490, and divide them by the total number in your data set. So the mean is going to be the sum of this thing, the frequency times the midpoint, each of those, which is 490, divided by n, which is 20. So that goes on top, that goes on bottom, and if you divide that out, you end up with 24.5 miles. That's the I kind of call it the weighted average, but it's the average number of miles there, the mean. Write the steps for finding a mean in group data. Well, we just did it. Make a table. So you've got class boundaries, frequency, then you got to find the midpoint. Then you're going to find the product of the table B and C. Find the midpoints. We did multiply the frequency by the midpoint for each class. Find the sum of column D, divide the sum of column D by the frequencies. That's what this one is. That's the sum of column D. And the number of your total data values, that's the sum of the frequencies.